Hi, my name is Lysias Brosson, and this is the technical breakdown video for my procedural hexgrid map generator. The main purpose of the plugin is to create a procedurally generated grid of tiles, hexagon tiles, using Perlin noise samples and user parameters to influence how the map looks. It's intended as like a building block or a prototyping tool for people who need like a map in games, like a Civ strategy game or something like. To just demonstrate it working as a plugin itself, we have the U plugin file here, and if we drag it into this empty projects plugin folders, if we copy it into here, and we go inside of it to get the dependent plugin, the plugin that it needs, like an external plugin, it actually needs to function, and then open the project, we'll see it appear normally in the content browser where it has all the blueprints necessary for it to work. So as you can see, this is a project with no functionality, like plugins or anything, that's just like in here. But what we can do is we can take the what is necessary, the map generation manager, and drag it into the scene and run it. We can see this UI open that lets us choose our parameters for the map, and then click generate, and it creates the map here. And we can regenerate the map using the same parameters, or we can give it new ones. And if we set it to like this, you can see this is an entirely different map. Looks and feels entirely different. Um, if we go into the level, the actual preview level, we can see it in effect in here, along with a preview UI that lets us scroll the map and regenerate the map. So there are three main blueprints to this. First is the UI blueprint that uses UI specific enums to create combo boxes and construct a map generation parameter struct that gets sent to the manager that we dragged into the scene. And the manager itself is responsible for creating the actual generator, passing it the seed and the parameters, and setting it to start world creation. You can see that the generation parameters struct are here, and the map size is broken into 3 enums, which you could add additional enums. Say, for example, if you wanted a larger map than large, you could go for huge, and that would give you a new pin to create more preset values in the manager. And the generator will take these parameters and interpret them in the map generation process. So if we actually go into the grid generator, we can see it assigning the modifiers, establishing an equator, which is just the center line of the map. This is important for temperature generation later on down the line. But after establishing the equator, we then go into the main generation process, and it starts by creating an array of data points. Tile data specifically, a struct made to store tile, like pertinent tile data, like row, column, where it is in the world, and its height and temperature values, which are the procedural parts of the generator. So you can see here we've got loops that go through that run equal to the number of rows and columns we've got based on the size set in the manager. There's a step for when assigning its position to make sure that every other row is offset correctly, because if it didn't, then the hexagon grids would just all be piled on top of each other, and it obviously would not create the grid impression. And during each loop, we sample the height and the temperature from our noise maps. So we start with the noise for height, sampling height, and you can see here the height modifier is being used as another slate node to add a value to whatever the Perlin noise sample is. It's also multiplied by a small value to ensure that we do actually see all types of tiles, like the full height distribution in maps. But the main modifying factor is this height modifier value. And that gets plugged into the struct and added to the array. Then if we go over temperature, we can see we've got that calculating. We know what the equator row is, but we can calculate the distance from it, express it as a we can express it as a percentage and plug that percentage into a lerp node, and that'll create the gradient from the center of the map outwards of like temperature values. But that would create just hard cutoffs and straight lines of these temperature regions. So what we've got is we've got the Perlin noise sample. Again, the value is modified by the modifier from the UI, and that is added to our lerped value to give it a bit more spottiness, to create a bit more variance and make sure that those borders aren't as like hard. And these get plugged into the tile data struct, and the struct is then added to the array of data points. Now that we have the data points, we can go through the each tile and compare the tile's values to values in a data table. The tile height table is first it goes through height and it checks the height values against the height data table. So you can see here that we have the enum type as well as what values it lies under. So if it was between 0.0 and 0.149, the tile would be an ocean tile, and that would be it. Ocean tiles don't currently have any subtypes in this version of the project, but this could be adapted so that you could have subtypes of oceans depending on what the project demands. But you can see we've got one for each type of elevation in the elevation enum, and if it can be subtyped or not. If it can be subtyped, we go through and we go through the heat data table as well, and we can see the values that are determined for, what's a desert, what's tundra, and what's just a normal temperate region. Otherwise, it's just set to ignore. Now that we've got those out of the way, each tile has its position, its sampled procedural values, and its enums. We can now start creating the actual visual element of the tile grid. And it starts with the visual table, which contains every combination of enums. So you can see we've got ocean and mountains, which are both in north, and you've got a cold flatland, a temperate flatland, and a hot flatland, and the same for hills. And we start by creating a instance mesh component for each type in that data table. And the reason it's an instance mesh is because they're faster and a lot less intensive than, say, creating a brand new static mesh component for every single tile. So we go through the tile data table and we compare it to the each and every instance that we have. And if they line up, then we add an instance of that type at the specified position to our grid. That's the basics. We can see that there is room for expansion in the data tables. We could have a lot more height values, like a lot more height enums, a lot more temperature enums, to create more combinations of tiles that can appear wherever. And we can increase the number of parameters we have, or even like entirely new generation types. That's sort of like what the plugin's made for. It's made for giving a baseline procedural generation thing process to build upon. Be it gameplay or more generation types or more like data to plug into the generator. Um, there is a bit of error handling because the actual samples create float values that are more precise than what is written in the data tables. Like it's at least like 6 more decimal places more precise than what I've written in the data tables. And rather than, make sure every data table has the same amount of precision, because there is no way of telling. There is a way that there's no real way of enforcing it or telling. So we've got a bit of an error handling where if none of the enums match up and an instance is not created, we add it to the array, and we find that tile's array's neighbor, array neighbor in the main array. So this would be the tile to its left, and we just make an instance of that instead and correct the data value so that it becomes that tile instead of just an empty hole in the map because no instance got created. And then once it's complete, the event dispatcher communicates with the manager, and then we have a post-generation event, which in this case it just creates like the preview UI that you saw in the example level. This here, which lets you scroll left and right, and has the regenerate buttons that we know. Although this entire step could be completely eliminated and replaced with whatever you want. The plugin is basic for is as like the manager is adaptable to whatever the project requires, like both pre and post generation. So um, that's the breakdown of the generation process and what the grid generator does. We can actually see it work when we've dragged it into the test level. This completely empty level, save for light. We can take this manager, the manager class. We could drag it into the level, and we can go generate, and the world generates just like that. It's easy to just click and drag this manager into the level, and it will handle creating the UI and creating the actual map generator. So that's pretty much everything we need to know about the grid generator, and I thank you for your time and thank you for watching.